Welcome to the K-State Regen Ag Pod, where we talk all things regenerative agriculture here at Kansas State University, across the state of Kansas, and beyond. I'm Nick Detter, your host, and I'm here today with Dr. Trisha Moore, Associate Professor of Biological and Agricultural Engineering here at Kansas State University, and we're here to talk a little bit about life cycle assessments. Thank you for joining us, Trisha.
For sure. Thanks for having me.
So I think just to start off, what I like to ask our guests is just tell us a little bit about yourself, your background, and how you got into your current position.
Okay, so I grew up in a small town in southeast Kansas and actually came to K-State for my undergrad. I ended up in a biological and agricultural engineering department as an undergrad because I was very passionate about natural resources. My dad's a wildlife biologist, and I was kind of, identified that as a path that really interested me, but I also saw a lot of environmental degradation that wasn't good for those organisms that I was interested in, especially in some of our aquatic systems. So I kind of steered that way to see, some of the engineering solutions to try to improve environmental quality. And then after I finished my bachelor's and master's at K-State, I went to North Carolina State University for my PhD and got familiar with some of the East Coast water issues, then slowly worked my way back to Kansas, did a postdoc at the University of Minnesota, and then started a faculty position back in my undergrad department at K-State, which is pretty cool, in late 2013.
That's great. And so it sounds like your work recently has focused on life cycle assessments. Could you tell us what is a life cycle assessment?
Yes. So as someone who's interested in environmental quality and the ability of different systems to achieve different environmental metrics, whether it's, water quality or helping support biodiversity, I found along the way that life cycle assessment is a really great tool to help us understand those systems. And so what life cycle assessment is it's a process for identifying and quantifying environmental impacts of a product or a process or a system over its entire life cycle. And generally, when we say life cycle, we're defining that to be not just when that product or system is being operated and used, but at its birth or cradle. Sometimes we say cradle to grave to define a life cycle. So, what it took to make that product or process or system, what it took even before that to extract the raw materials or other natural resources that go into producing that product, all the way through its disposal or kind of end of life. And so it's intended to be this very holistic type of process that's also repeatable, because when we say something like, oh, it's good for the environment or it's sustainable, those are kind of, how do you define that, right? And so life cycle assessment is intended to give us the tools in terms of the metric and a systematic method for quantifying various, in this case, it's looking at the environmental impact side. So opportunities to reduce impacts or avoid impacts would lead to something that we think is more sustainable. So,
yeah, that's very interesting. And I think that definitely fits into this broader idea of regenerative agriculture and how our farming systems can be evaluated for their impact. So could you talk a little bit about how specifically a life cycle assessment might play itself out when analyzing agricultural systems, or kind of in this broader context of regenerative agriculture?
Yeah, absolutely. So again, a lot of us have a feel that regenerative agriculture systems should be better for the environment, should be more sustainable. And so applying the life cycle assessment as a tool to systematically, again, look at those benefits or impacts to the environment through a regenerative agriculture system, it provides a way to kind of benchmark, I guess, against a more traditional or conventional, less regenerative way of producing and supplying our nations like food and fiber. And so in that case, when we're doing a life cycle assessment of a regenerative agriculture system, it's a little different from where life cycle assessment began, which was primarily used by, beverage companies to understand if they should use glass or plastic bottles. We know where that assessment ended us up. But an regenerative agricultural system really is a system. It's a more complex system. And especially when you start having systems where you have multiple crop rotations, or you're maybe even integrating livestock. And so the great thing about a life cycle assessment is you spend a lot of time just defining that system and understanding how not only do you have different cropping system or cropping cycles, but also some of the aspects of the soil and building soil health and what that can result in. But ultimately, when we do a life cycle assessment with a regenerative agriculture system, we're interested in what's going into the system. So what are the inputs? How much fertilizer is being used? Irrigation would be another one we could consider. The fuel that's being used to till or to maybe to not till the field. And then what's coming out of it. So we're interested in whatever the product of that system is. It could be corn and soybeans. It could be some livestock. It could be a whole suite of things. And so that's part of defining that system. But then we're also thinking about, well, what are the outputs in terms of maybe like greenhouse gas emissions or fertilizer that's lost in through your runoff or leaches into groundwater. And so thinking about those other ways that the things we put into our system might leave the system. And those are the types of outputs that we can attach some environmental impact to potentially through the life cycle modeling process. So it's a good way to, again, to kind of benchmark where a system is, and then as your inputs potentially change in a regenerative agriculture system. For example, if you just reduce the amount of tillage, you're going to have less fuel going in. And because a life cycle process is very holistic, it's not just avoided fuel, but it's avoided extracting that fuel, and it's all of the energy and other natural resources that were required to produce that fuel. So it really goes, far up the supply chain there.
Yeah, it sounds like it can be a very powerful tool, potentially. I like how you said we like to think that these regenerative systems are better for the environment. Do you have, with this tool of life cycle assessment, have you found in either your own research or other research in the field, what evidence do we have that supports either the benefits or non-benefits of these regenerative agriculture systems in terms of their life cycle assessment results?
Yeah. So some of the work, I've been working with others like K-State, Dr. Chuck Rice, and a postdoc, Peng Chen, and then also a colleague at University of Arkansas, Dr. Marty Matlock. And we've been looking at a couple of case systems. And one of those happens to be in Brazil, which is pretty different climate and otherwise, so every system is going to be different, of course, depending on its kind of ecological context. But what we're finding there is their various suite of approaches that they're taking to be regenerative. So, the way that they till, and especially the crop rotations, and selecting plants in those crop rotations, cover crops, if you will, that they can graze, that have really deep root systems and put carbon far down deep into the soil, that when we start looking at that system from a life cycle lens, we see, lower, because those farms actually are using less fuel. We see that on the inputs when they give us their data, like this is how much fuel we use. And their fertilizer especially, it was amazing how little additional nitrogen fertilizer, for example, was going into that system, because through their crop rotations, for example, and some of the other bioinoculants and things that they had going on at that farm, they're able to, lock more of the nitrogen in the soil. Again, from a life cycle assessment stage, what we see is the lower input of nitrogen, which from a life cycle assessment is going to save all the production further upstream. And then, of course, if you were tagging on an economic analysis, you would probably also see some cost savings for those systems. In addition to, so the main, from a life cycle perspective and avoided environmental costs, the main thing we are seeing from that type of system is lower fertilizer use. And then they were just able to do a lot, by integrating these crop rotations with their livestock grazing. They're able to avoid a lot of imported feed, for example. And if we were looking at that in a life cycle assessment, well, we had to harvest it somewhere else, and we had to truck it there. And so we have all these, environmental impacts that can accrue through all of those different steps. Well, on this farm, they were able to eliminate that because they were doing it all on their own, within their own system. Another big piece there is that because they have, they're so tight with their nitrogen and keeping it in the soil in forms that are less likely to leave through, say, runoff or leaching to the groundwater, or even like being emitted as a kind of greenhouse gas. They've really minimized some of the environmental impacts that we quantify related to global warming potential, for example, with greenhouse gases, or water quality with respect to nutrients that are leaving through your runoff and getting to a stream or lake or ocean downstream of you. So those are some of the main impacts that we are seeing that would be higher in a less regenerative system, but that are being mitigated in this very closed, cyclical type of regenerative farm system.
Yeah, that's very encouraging. It sounds like the practices that we're preaching might actually have some data to suggest that they are having these positive impacts.
Yeah.
Another question I had about life cycle assessments are, how do you anticipate, farmers here in the U.S., here in Kansas, maybe interacting with these tools? Is this something you see them, applying to their own farms to see how their system is playing out? Is this something, I know, there's a lot of conversations around carbon credits and how those things are being measured and how companies may be analyzing, our farms here in Kansas. And then even, could there ever be like a policy component to any of this about how, policies are being made? Right. So I guess how do you foresee life cycle assessments being a tool that help us evaluate our agriculture systems here in the U.S. and in what ways may our farmers may be interacting with this tool?
Yeah. So I think that having an understanding of how life cycle assessments work and really their broad scope is very helpful for anyone that's, thinking about environmental impact of their systems. Because again, like for an agricultural system, when we think about, say, like carbon credits, it's, there's a lot of focus on building the carbon store in the soil, and that's part of building a healthy soil. And we can do that, for example, with cover crops that give you some additional root structure and moving carbon down there, or, through removing less of the residue and allowing that to build up in your soil. But there's also very important impacts to that overall global warming potential when you think about, again, like offsetting things like fertilizer. If you're not putting industrially produced fertilizer
like
into
nitrogen and phosphorus.
Exactly. Then that's a whole up system chain of avoided greenhouse gases. So thinking about it holistically, building the carbon bank in your soil for sure, but then also being able to be credited for offsetting other greenhouse gas producing processes by just not needing those inputs anymore is a great opportunity, I think, for producers in thinking about being able to market their product as being climate friendly. And of course, environmental life cycle assessment allows us to go beyond the climate piece, but we can think about how these systems are contributing to biodiversity by avoided impacts through toxicity of various chemicals that might be avoided or just applied at lower rates because the system just doesn't need as much at some point. And so I think that it's a great tool for quantifying those things, and it helps us to think about, some of the more obvious pieces and just are what right in front of us, but taking credit, again, for those avoided emissions or inputs that we can have. From a policy piece, that's a very interesting question. I think that some of this, because a lot of my work has been in the water quality area. So, again, life cycle assessment gets at a lot of different environmental impacts, and some of them do relate to water quality. And so I think that, by quantifying how a system is performing in terms of these different impacts. And again, we expect those impacts to reduce as you adopt more regenerative practices, that it allows people outside of just the greenhouse gas climate community to say, hey, this is pretty cool. Because when you start to see, for example, reduced impacts to water quality, or you start to see more opportunity to reduce impacts around biodiversity or ecological health. Those are different communities of people, of consumers, and they might care about your environmental impact in different ways. And so I think it helps to attract kind of a broader set of interest to the potential for agriculture and regenerative agriculture to address some of the environmental challenges that we have. So that's something I also think is good about life cycle assessment, is it helps us to think beyond, just to avoid getting too focused on just one type of impact. But again, thinking about all the impacts. But again, that's an opportunity to, get interest from other diverse stakeholders who might be interested in supporting regenerative agriculture.
Yeah, absolutely. I mean, I think, like you said, these they're systems. They don't just address the carbon cycle. They do interact with the water cycle and the nitrogen cycle, and so it really does sound like this is a tool that can help us evaluate our agricultural systems as a whole and consider all of their inputs and outputs and how that's impacting our environment and like you said, even economically, like helping us factor in those things as well.
Yeah.
So I think the last thing I just wanted to ask you, this is the question we finished with all of our guests. What's just something that's exciting you in your research right now? I mean, it can be related to regenerative agriculture, but we just want to expose our audience to all that's going on here at K-State and academia at large. And so what are some things that really have you excited going forward in the work that you're doing?
Yeah. So a lot of my work is in hand-in-hand or in partnership with state agencies or nonprofits or kind of other a broad stakeholder group, I guess. And as I mentioned previously, life cycle assessment helps us look kind of broadly across environmental impacts. I think, though, I'm a positive person, so I like to think about the benefit side too. And so, part of my work has been applying life cycle assessment as a tool, but there are other metrics that relate to not just avoided impacts, but created benefits. Mm-hmm. And so, one of those ways of looking is through what we call ecosystem services, which are benefits that natural systems or ecosystems provide to us, to provide to society. And so, again, it's kind of like two sides of the same coin between life cycle assessment looking at environmental impact and ecosystem services looking at environmental and related societal benefit. But I'm really excited about opportunities to kind of pair these two ways of looking at systems because it's avoiding impacts is great, and life cycle assessment provides us with a metric to understand how effectively we can do that through different strategies. For example, in ways that we might adapt a regenerative agriculture system. But then thinking about the ecosystem services, again, that's, I think, another way to bring in, diverse stakeholders when we start thinking about, well, you've created, through incorporating some. Let's just say, for example, your regenerative system might have some native grass strips in it, and so there might be pollination potential there. And that's something we can quantify through ecosystem services that we can't do very well with life cycle assessment. So I think there's, opportunities to pair these two ways of looking at things. Because when we can talk about both the impact avoided as well as benefits created, then you can talk to more people about how cool or how impactful your way of, going about and growing food, fiber, and, has these other tangible benefits to us. So, yeah, that's what excites me is thinking about regenerative agriculture systems as ecosystems and how they're managed ecosystems and how, we can try to manage them to do more than just produce food and fiber, but to provide some of these other benefits. So, I think that's really interesting. Could you speak a little bit more to how, you mentioned the example of the pollinator strips, or are there any other examples you can think of the ecosystem services? Is that what you call it? Ecosystem services.
Ecosystem services that our agricultural systems can provide?
Yeah, I would love to. Absolutely love to. So one of, I'm just going to use an example and also give a shout out to my friend at KDHE, Scott Satterthwaite. He's really pushed from his state agency position this concept of soil health, not just for helping, there's the food production aspect of that, but for those of us water people, there are downstream benefits. So when you build soil health, you're also building a system that can hold more water in the soil when it rains, that filters that water so that when, communities downstream, for example, when it rains and runs off, you have fewer pollutants coming in that water. You may even have reduced flood peaks, for some of the really big storms, just because you can take the top of that off by holding more of it in the soil. And so that's a case where, this ecosystem services of thinking, beyond avoided impacts, but also what benefits you might be providing downstream. And that produces this opportunity for partnerships too, and interest in this case, from a community downstream that appreciates the service that a regenerative agriculture system can provide in terms of, controlling the hydrology, or the way that water is entering into our water system, and as well as the quality of that water. So I think that's another that would be an example of kind of this ecosystem service lens and how it links and true benefits can be provided, and we can try to quantify those. So
I think that's great work, because I know that sometimes in the ag community, it can feel like we're cast as the villains or the source of environmental problems. And so I think your work is really exciting, and the work at KDHE of like, how can we reframe this to see how ag communities and ag producers can be part of the solution and can see that their work is a benefit to society on these environmental questions. I think just the last question that kind of came to my mind as talking with you is, I know one of those specific water quality issues is around the algae blooms.
Yeah.
Do you have any thoughts on that and how that relates to some of our ag systems?
Absolutely. I'm so glad you asked. So by and large, in Kansas and many other agricultural states, like our water bodies they have plenty of nutrients. They become very productive. And if you're an algae in that system, that's great. But as we know, we have various types of algal blooms, some of which are harmful, toxic, cyanotoxin blooms, for example. And so if we can control the nutrients going into those systems, then we can start working our way to address those water quality issues and algal blooms. And, some of the work, for example, that we've seen in Brazil, and there's other groups, and, it's not just Brazilian systems that are capable of this, but when you're able to tighten up the nutrient cycling and thereby reduce the amount of nitrogen input and then leaving a farm, that's a big part of helping nudge a system away from this overproductive and even tendency for toxic algal blooms. And so there are some great examples in Kansas, again, where it's understood, and communities, which are primarily some of the users of those waters, and it costs more to remove toxins as well as some of the taste and odor compounds that they produce. So there have been some pretty concerted efforts, I think, for communities to work with upstream agricultural producers, again, recognizing that they have a big role to play in helping to manage the nutrients coming to our water bodies, if it's leaving from their farm. And so Kansas City region, for example, has partnered with agricultural producers in the Milford Lake watershed, which is one of Kansas's large reservoirs, and eventually that water, gets to the Kansas River and down to Kansas City. And so they are actually, will fund payments upstream to help implement, because we do recognize, right, that comes with a cost. It's a change in practice, or maybe it's an ongoing cost, like incorporating cover crops, for example. And so, but because there's a service or a benefit that can be provided, it creates this other income stream in this case to try to help reduce the impact in helping our waters get back a little better. So. Yeah.
Well, that's great. I mean, I'm just so grateful for you coming on and joining us today, for your perspective. I think, a lot of times our audience gets to hear a lot about how these practices have their on-farm impacts, and I think that's great. But I think your work and what you're talking about really demonstrates that if we can get these regenerative agriculture systems to work on our farms, not only will they positively affect the farms and the farmers there, but they can have societal-wide positive impacts as well. So
Absolutely.
We're so grateful for you joining us and talking a little bit about how all that is working out. And we just want to thank you all for joining the K-State Regen Ag Pod. If you're interested in learning more about Dr. Trisha Moore's work, we'll be sure to include her contact information in our show notes. So we'll see you guys next time.
Oh, give me a home where the buffalo roam, where the deer and the antelope play, where seldom is heard a discouraging word, and the skies are not cloudy all day. Home, home on the range, where the deer and the antelope play, where seldom is heard a discouraging word, and the skies are not cloudy all day.